Let us see about the equation of lines. The equation of lines is normally mentioned by y is equal to mx plus c. This is defined as the general equation of lines. Here y is an dependent variable which depends upon the value of x, and m is known as the slope of the line. The slope refers to the steepness of the line, how steep the line is. When I consider it as an x-axis. If there is a line here, it is like, and here a line, and there is a line here. Let us consider it as line L1, L2, L3. By seeing the line itself, we can say the steepness is more in L3 and it is little bit lesser in L2 and little bit lesser in L1. We can say that when we keep an object here, if the line is more steep, the object will fall very fast. When I compare these three lines, the object here will fall down very fast when compared to the objects in the line L1 and L2. It also depends upon the angle it makes with the x-axis. When angle is more, and hence the slope is also more. When angle is more, then slope is also more. We can say that slope is directly proportional to the angle that which the line makes with the x-axis. Here there are some different types of line we are going to see about it. Okay, so when I consider an x-axis and y-axis, let us redraw this again. So I will just explain you clearly. If I am having the lines, let us consider line L1, L2 and L3. L1, L2 and L3. And the line L1 makes an angle theta 1 with respect to x-axis and theta 2 with respect to x-axis of the line L2, and theta 3 is the angle made by the line 3 with respect to x-axis. Now we can see when I keep an object at the end of this line, obviously the object in the line L3 will come faster. So when compared to the objects in L2 and L1, now see the object in L2 will come very fast when compared to the line L1. So from this we can say the slope of L3, let us consider that as M3, is greater than compared to the slopes of the line L2 and L1. So from this I can say theta 3 is the greater angle when compared to all the angles, and hence the slope of the line 3 is greater than the slopes of the other lines. This is the way we have to find the slope. So now to find the slope, the formula we'll always use is tan theta. Tan theta is the formula we'll always use to find the slope. So the formula is m, that is equal to tan theta. We can directly substitute the angle here. So before moving into this, again we have to recall about the quadrants. Quadrants is very important even in trigonometry, like allied angles and compound angles. In that quadrants, let us consider the four quadrants, x-axis and y-axis, and here. So the quadrant here is 1, 2, and here it is 3, and here it is 4. In all the way, the angles here is considered as 0 degree, and it is 90 degree. Here it is 180 degree and 270 degree, and it is 360 degrees here. So there are 6 trigonometric ratios, which is sine, cos, tan, secant, cosecant and cot. In these 6 trigonometric ratios, not all the ratios are positive in all the quadrants. In quadrant 1, in quadrant 1, all the ratios are positive. We'll say that as A. In quadrant 2, the sine and its inverse cosecant are positive. Sine and its inverse cosecant are positive. And in the third quadrant, the tan and its inverse cot is positive. Tan and its inverse cot is positive. And here at last, cos and secant is positive, which means in the respective quadrants, the respective trigonometric ratios are positive. Other than that, everything is negative. For this, we can use that adventurous soul travel continents. A represents all the ratios, S represents sine and cosecant, T represents tan and cot, and C represents cos and secant. So you can use this way to remember which is positive or negative, and there are more ways to memorize it. So now here, when we take the shapes of the line, that can be either in two ways. If I consider a line, see, if I consider an axis x and y axis, this line that can be passing through this way, or it can pass through this way. So when I consider, see here, the angle should be always calculated with respect to the positive x-axis. So if I calculate the angle here, it will be this. Consider that as theta 1. But if I want to calculate the angle made by this line, so from here, if I calculate this, will be the angle theta 2. So we can say that here in the first and third quadrant, the tan will be positive, and here in the second and fourth quadrant, the tan will be negative. And also we know that when theta 1, which is lesser than 90 degree, that kind of slope will be positive. And if theta 2 is greater than 90 degree, and that slope will be what? It is negative. If it is negative, so and this is the reason we can use the tan theta for solving the slope of the lines. So let us consider two types of lines in which the slope is either positive or negative. Let us have the differentiate. So here let us consider this as x-axis and y-axis, and here it is x-axis and y-axis. So we can make an angle which has positive slope. If m is positive, we can have three chances. Either it can pass through the origin, or here, or above. These were the three types. So we know that general equation of line is y is equal to mx plus c. So here the slope is a positive value, and this c represents the intercept, so which it cuts the x-axis. So the distance from the origin where the line cuts the y-axis, that is known as intercept. So consider this as the line 1, and this as line 2, and this as line 3. So in line 1, we will be having the equation as y is equal to, and slope is positive, so consider that as a positive value m x, and c, it is passing through the origin, so it will be 0, and so the equation will be y is equal to mx. Into the second equation, see here the intercept which is in the positive, okay, so I will be getting the value y is equal to mx. So consider that c as plus c. That will be the equation of the second line. For the third line, see here the intercept is below the x-axis, which is on the negative y-axis. So I can write that as y is equal to mx minus c. So this will be the equation of a line which has a positive slope. Similarly, while coming into the negative slope, m is negative, I will be having three different lines. So here neither the line can pass through the the line can pass through the origin, Either the line can pass through origin or here or here. Let us consider, so it is a line that is passing here, and see here the angle is greater than 90 degree, so obviously it covers the it passes through the second and fourth quadrant, and also the angle is greater. So from this I can say that the slope is negative. So I know the general formula of the equation is y is equal to mx plus c. Now see here, if I consider this as line 1, and here it is line 2, and here it is line 3, the line 1 that can be written as y is equal to mx plus c, and there is no intercept, it is passing through the origin, so it is 0. So the first line equation will be y is equal to mx, and we know that the slope is negative, so instead of this m I should write it as y is equal to minus mx. It will be the equation for the first line. So and also for the second equation, y is equal to minus m into x, because the slope is negative, and also it has the y intercept which is above the x axis, so I'll just mention it as plus c. So the equation will be y is equal to mx plus c will be the equation of the second line. For the third line, the intercept is below the x-axis and it intersects on the negative y-axis, so it will be y is equal to minus mx minus c. So these are the equations of the straight line. From this we can able to solve the questions. So how the straight line equations can be used in the physics questions, or they can ask the graphs between the velocity versus time. When the velocity versus time graph has been asked, it will be the straight line, and the slope of that line will gives you the acceleration. Slope of that line will give you the acceleration. Similarly, when they are asking about the displacement versus time graph, the slope of that line will gives you the velocity. So this is very most important one in case of line, so that you can revise it.